Statistical Process Control, or SPC, is a quality control process typically used in manufacturing. The goal of SPC is to identify special causes for the variations in data and correct them to ensure a stable and capable system. A system could show variations in data and be completely normal. That is because these variations are produced by what is called a common cause. For example, the time it takes you to drive to work each day will be slightly different based on the traffic. Traffic here is a common cause. The other cause for variation is called a special cause. These causes do not occur normally and are the underlying problems that need to be fixed. In computer and electrical engineering, SPC is widely used as a means to observe and modify the heat output of a system. Let's take CPU engineers at Intel as an example. They make good use of the SPC when they try to increase the clock speed of their CPUs to as high as possible without having the CPU going over 85 degrees Celsius under heavy workloads. They don't want the system to run too hot because, as you know, heat is the enemy of all electronics, since power is directly related to frequency, and as heat is the byproduct of power, heat is linearly related to frequency. If you have a computer at home, you can experience what working as a CPU engineer feels like by overclocking your system. I have measured the stock performance of my CPU and have made an SPC chart of the heat output to use as a baseline for my overclocking. The SPC chart shows the behavior of the process over time, so I can use it to monitor my computer's heat output throughout multiple stability tests. In the graph, the two borders about the data points are called the upper control limit and the lower control limit. They indicate the point that is 3 standard deviations away from the mean, and anything over the upper control limit or under the lower control limit signals an unstable system. The second graph shows a successful overclock. The third graph shows one of my many failed attempts. Although all the points in the third graph lies within the control limits, the 3 outliers causes the system to crash. There are many more conditions that signal out of control system than just going over the control limits. The high skewness suggests that the variations are not normal. One of the rules states that if there are 3 points that are more than 2 standard deviations from the center line, and 2 out of 3 points lie on the same side, then the system is out of control. In our third graph, the 3 outlier points also lie more than 2 standard deviations away from the center line. The full list of the out-of-control signals will be in the description of this video. In short, statistical process control is extremely helpful when you need to measure the stability of some arbitrary system. It is not only useful in manufacturing industry, we can also use it in our everyday life to improve our productivity, as with the overclocking example.